Hey, fourth graders. So today we are going to be looking at how to solve problems in comparison situations where we're looking at how much somebody has of something in comparison to how much somebody else has of something, or how many points a team has in comparison to how many points another team has, or how far somebody has to travel in comparison to how far somebody else has to travel. And all of these are going to be in the form of word problems. And so if you watched the very first video that was linked on the videos page, you saw it was called Math Keywords in the Cube Strategy. And in your math keywords, just as a quick recap, are words that signal whether we're going to add, subtract, multiply, or divide. And if we remember what it means to add, what it means to subtract, what it means to multiply, and what it means to divide, it's pretty easy to figure out what words would be math keywords. Comparison problems have those math keywords in them too, and we can also still use our cube strategy to solve the problems. But I'm actually going to show you a different strategy that's really similar to cubes, but it's just looks a little bit different. So again, everybody's brain works differently, even when solving word problems. And so this strategy would possibly be helpful for you with solving word problems. One other tip that I always have for solving word problems is for you to draw pictures as much as you can. Because when we draw pictures, we're able to see what the problem is telling us. Okay, so let's go ahead and take a look at this problem. And I was just realizing I needed to pull out my notes really quickly so I make sure I don't forget something. Okay, so here we go. We have Naomi and Cora were playing with their dolls. Naomi has 9 dolls. Cora has 3 times as many dolls as Naomi. How many dolls does Cora have? All right, so I've read through the problem once. Remember, in the cube strategy video, I also recommend reading through word problems more than one time because it's really easy to miss information. A lot of times we're trying to read and finish work quickly, and sometimes the wording of a word problem can be a little tricky. Now, this one's not really so tricky, but there are times when the person who wrote the word problem might give us a little bit of extra information that we don't really need, or things might be in a kind of different order or worded in a way that we're not super familiar with. And so if we read it just one time, then a lot of times our brain goes, what? I don't get that. And then we just get frustrated and we stop. Well, if you remember all the way back to our very first live lesson together, when we talked about productive struggle, we talked about we don't just stop. We have to have strategies and we have to have tools that we use to help us to figure out tough math problems. And one of those strategies is going to be to read through the problem again. And another strategy that I'm going to show you guys today is kind of like cube strategy, but it's called the KWS strategy. Now, you guys have probably done KWL, like what I know, what I want to know, and what I learned, right? You've probably done a KWL chart. A KWS chart is very similar. So I'm going to write one over here. So we have KWS, and we have the K is still, what do I know? I'm just going to write single words because I wrote it kind of small. And then the W is, what am I trying to find out? Okay. So I'm going to just change that to solve just so it's less words. And then this is where we're going to, how do I solve? So you guys can see this is a lot like the cube strategy, right? Where what we know would be, okay, well, Naomi has 9, right? If I read back through again. And I know that Cora has 3 times, and I'm going to write times like that just to save space, as many. And what do I want to solve? I want to solve how many, so this is like underlining the question, right? Dolls does Cora have? Okay, and here, how do I solve? So right here, I've pulled out my numbers, right? That's the C. Circle the numbers. I've pulled them out. I have my keywords. I have times as many in there, right? That's a keyword. And I know what I need to solve. So it's like underlining the question. So if you don't want to write directly on the problem, or maybe you're doing the problem on your computer screen and you're like, well, I can't circle the numbers and underline and box and do all of that, this KWS chart might be a better strategy because you can write this on your paper. Okay, well, how do I solve? Well, I have to think about what I know. All right, what do I know? I know that Naomi has 9 dolls. So I'm going to draw this little bar thing, and this is 9 dolls. All right. I should have drawn this a whole lot smaller, I'm realizing. I'm actually going to see, sometimes teachers make mistakes too, and that's okay. Everybody makes mistakes, right? All right, let me try this again. I'm going to try this again right here. And again, if I had a pencil, I could just erase that, right? So I have Naomi. I'm just going to write an N. And this little box stands for her 9 dolls. Okay. Cora has 4 times as many. So we have to think, who has more? Cora has 4 times as many. So Cora's dolls are 4 times as many as Naomi's dolls. Cora's has for every 9 dolls that Cora had, or that Naomi has, Cora has like 4 of those. That's what times as many means. So Cora's would be like 9 dolls 4 times, right? And I'm just going to draw a long one. See, that's where I made my mistake. And this is 9 dolls, and this is 9 dolls, and this is 9 dolls. All right, so Naomi has 9. Cora has 4 times as many. Well, I've said times as many a whole lot. Times is another word for multiply. That's right. Times is another word for multiply. So we are going to do 4 times as many as Naomi has. Naomi has 9. Cora has 4 times as many. Okay. Another way that I could represent this if I were drawing it would be to draw an array. Okay. So Naomi has 9 dolls, right? So I'm going to draw little dots because you guys know I'm not a good artist. 4, 5, 6, 7, 8, 9. Okay. Cora's are 4 times this. So I have to do this 4 times. Okay, times as many. That means I have to do it 4 times. So I've done it once. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, if I don't know 9 times 4, I can just count and see how many dolls Cora has. All right. So how many dolls does Cora have? Well, I'm not going to spend the time to count them right now because I do know what 9 times 4 equals. It equals 36. So Cora has 36 dolls. Okay. So that's one example of a comparison problem. Let's look at one more example. All right. So now we have Corin. That's my son. Naomi's my daughter and Corin's my son. So I'm using them as examples today in their problems. So Corin has 4 times as many. But you know what? I just realized something, guys. I did this whole problem wrong, didn't I? You are probably sitting there like, this is long. It's not times 4. I was thinking about the other problem. What should I have multiplied by? I should have multiplied by 3, right? So this should have been not there, and this row should have been not there. That's why it's always good to go back and check your work. And this should have been 9 times 3. What does 9 times 3 equal? That equals 27. So Cora has 27 dolls. I am really sorry about that, guys. I totally just, as I turned the page over, I was like, wait a second. I know I didn't put the same exact thing on both problems when I wrote them. And I realized I made a mistake. But we do that. I've noticed that students do that sometimes where they see one number, I wrote it correctly here, and then I changed it. Okay, so that's always important to go back and double check your work to make sure that you're doing it correctly. All right, I'm glad I was able to show you that. All right, let's try this again. Corin has 4 times as many Lego bricks as Micah. Corin has 584 Lego bricks. How many does Micah have? All right, so if we do our KWS chart, okay, what do I know? I know that Corin, I'm just going to write K, has 4 times as many Lego bricks. You know what I've learned, guys? I don't know if any of you guys have ever watched the show Lego Masters, but they're not called Legos with an S. They're called Lego bricks or Lego singular. I didn't know that. I always called them Legos, so apparently I've been saying it wrong. All right, there we go. All right, so Corin has 4 times as many Lego bricks, and Corin has 584. And I'm just going to write 584. And we know that Micah has Legos, right? So we could write that. But what do we want to know? How many does Micah have? So again, we want to read and think about this problem really carefully. We know 2 things about Corin, and we actually don't know much about Micah other than that he has Lego brick, right? So what does that mean? Okay, now when we see times as many, we automatically want to multiply, and that's what I see happen a lot. But we have to remember that that's not always the right way to solve the problem. So let's look at what we have. All right, Corin has 4 times as many. So the person who has the times as many is the person who has more. All right. And if we remember, like if we were representing this as a multiplication problems, that means I'm going to use M for Micah. Micah times 4 is going to equal the 584. Okay, Micah's bricks times 4, because 4 times as many, is going to equal the 584 bricks that Corin has. So Corin has more, right? It says that right here. Corin has 4 times as many. So anybody who has the times as many is the person who has more. Okay, that's really, really important to remember. So what am I actually going to do to solve this problem? Am I going to do 4 times 584? I'm not, right? I'm going to look at this and say, well, to find this out, I have to use the inverse operation. What's the inverse operation for multiplication? Division, that's right. Remember, inverse means opposite. So the opposite operation. Addition and subtraction are inverse operations. Multiplication and division are inverse operations. So in this case, I actually have to divide to solve. And I'm like, oh no. I don't like division, right? I hear that so much from students, but that's okay because remember we have a really cool strategy where we can draw pictures to help us to solve division problems. So I'm going to draw 584 using place value blocks. So we have 500, so that's 100, 2, 3, 4, 580, 1, 2, 3, 4, 5, 6, 7, 8, and 4. 1, 2, 3, 4. Okay. Now I know that there's 4 groups, right? I'm splitting this into 4 groups. So I have 1, probably should have drawn my groups a little bit bigger, 3, 4. All right. And now I'm going to distribute these because that's what division is, right? It's distributing something among groups. So these are the Lego bricks, and I'm going, here's some for you, here's some for you, here's some for you, here's some for you, right? And luckily, at the first few Lego bricks, I can grab in groups of hundreds. So 1 for you, 1 for you, 1 for you, 1 for you, right? And I still have 1. So now I'm going to split this into tens, right? 100 equals 10 tens. So I'm just going to add them right here by my tens. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So now I've used that because I just split it into tens. And now I'm going to distribute my tens. So 1 for you, 1 for you, 1 for you, 1 for you. Another way you could do this would be count how many you have and then just go 1, 2, 3, 4. That might actually be a little bit easier. So let me see how many I have left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yep, okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, if I do 13, 14, that's not going to work. So I have 2 10s left, and I have to split those into ones. So that's going to make 20 more ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So now I have 20, 21, 22, 23, 24 ones, and I'm going to distribute those. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Got all those ones taken care of. All right, so how many does each of these groups get? Remember, each group would represent like Micah. So this group right here is Micah. That's his Lego bricks. How many does he have? He has 100, 10, 20, 30, 40, 41, 42, 43, 44, 45, 46. Micah has 146 bricks. All right? And that right there is my answer. Okay. So again, with the multiplicative, wow, that's a tough word, comparison, we want to think we're seeing times as many, and times as many means multiply usually, but it's really important to remember who has more. Okay, and that's kind of your key, because sometimes you are going to have to use division to actually figure out the amount that somebody has. All right? As always, if you have any questions, ask your math teacher, and I'll see you in the next video. Bye, guys.